Hello guys, and welcome to the final lesson of our Intro to Kotlin tutorial. In the previous section we had our basic intro to classes and objects, and now we're going to expand upon that by exploring the concept of subclassing and superclassing. So please make sure you're fairly comfortable with what we covered previously before moving to this section and finishing things off. So before we get started writing any actual code, I'm going to explain the concept of subclasses and superclasses, and I'm going to use our clothing class to help us. So this is a kind of a weird relationship in which the subclass of a particular superclass knows everything there is to know about the superclass. So it knows all of its methods, all of its variables or fields, all of the constructors, everything there is to know, but the superclass actually knows nothing about the subclass. As well, the subclass inherits everything from the superclass, hence why it knows everything. And so this means that if we had a subclass of clothing, it would also inherit these variables here, the isClean, name, and size. It would inherit these constructors, so it could use these constructors as its own, and would also inherit this method, in this case, wash clothing. Okay. On the other hand, our superclass, actually, even if it's being subclassed, our superclass knows nothing. Nothing changes about the superclass. As well, a subclass can define its own methods, and variables and constructors, and can even provide very slightly different implementations of the superclasses, variables, constructors, and methods. So I know that's kind of difficult to see without some kind of an example. So let me talk about an example and then we'll go ahead and implement it. So consider this generic clothing class. There's a reason I made it very abstract, in that it can only have a name, a size, whether or not it's clean, and then we can just wash it. So there's no like number of sleeves, length of the sleeves, anything like that, because clothing can encompass a massive range of different articles of clothing. Consider, for example, shoes. Shoes are very unlike a t-shirt or a pair of pants or something, in that they have vastly different properties and slightly different behavior. But essentially they're all pieces of clothing and they share some common attributes. So for example, a t-shirt will have a name maybe, it will have a size and whether or not it's clean, and we can also wash it. But also a pair of shoes will have a name, a size, whether or not it's clean, and we can also wash a pair of shoes as well. However, a pair of shoes and a t-shirt can have two vastly different sets of properties, but share some similar properties. So this is where the concept of subclassing and superclassing comes in really handy, because we can make the pair of shoes, or shoes class, a subclass of clothing, which means that shoes will get this name attribute, the size attribute, whether or not it's clean, it will get access to this method, and it will also be able to use these constructors. Similarly, we could create a t-shirt class which could do all the same stuff, but then we could implement extra variables and extra methods inside of the t-shirt class, and the same for the shoe class. And this is really cool because it enables us, getting tongue-tied, to eliminate the amount of lines of code we have to write. This way, every time I create a new shoe class or something like this, I don't have to again specify my name, size, clean, constructors, and wash clothing. I can just use my superclasses stuff. So actually, let's launch right into a code example where hopefully it will be a little easier to see all of these concepts I just talked about. We're going to go into our main package here and create a new Kotlin file or class. Let's make sure this is a class, and let's follow up with that shoes example. So you can call this class shoe or shoes, doesn't really matter. Okay, so let's get rid of that, don't want that. And now we want to declare that shoes is a subclass or a superclass of clothing. And the way in which we do that is by adding a colon and then the name of our superclass, in this case, clothing. Okay, now there's going to be a few errors here. The first is that clothing is what's considered a final class, which means it can't be subclassed yet. So all we have to do is declare this to be open, and that gets rid of one of the issues. This issue still remains, and that is that clothing has two constructors. It has to take in a name and a size, or a name, size, and whether or not it's clean. So at the very least, it needs a name and a size. Well, because shoes is a subclass of clothing, it has to take in at least those attributes, or in some way set them up. So we're actually going to take in here, in the primary constructor of shoes, a name of type string, and a size of type int. And then we're just going to use our superclasses constructor. We're going to pass in just name and size. And that gets rid of the issue. So this is a primary constructor for shoes, but the way in which it reads is we pass in a name and a size here. It sets up the shoes, but before it can set them up properly, it's actually going to call on our clothing's constructor. It's going to call on this guy, which is going to use this implementation here. So if we had extra attributes in here that it was setting up, it would do the same in the constructor that we called here. Okay, so really cool. We get to implement the constructor only once, but get to use it over and over again in multiple subclasses. Now, I'm fine with these constructors. I'm not going to implement any extras, but I will add some extra variables and some extra methods. So what would shoes have that make them unique to clothing in general? We can think of lots of things, but consider first the example of laces. Shoes may have laces. I'm not going to explore the concept of Velcro or anything. In fact, to be specific, let's say shoes with laces. That way there's no confusion. Okay, so these shoes will have laces, whereas other pieces of clothing might not. T-shirts usually don't, unless they're, kind of fancy. Pants may or may not have laces, but again, usually not. So we're going to create just a couple of variables to help us out here. We'll have a variable that is going to be laces name. I don't know, let's just set this to be a string. Maybe this will be the type of laces or something. And actually, we're going to use some concepts that we learned previously. Let's make this nullable. We'll just set this equal to null for now. We'll have a variable that is going to be our laces clean. This is going to be a boolean, which we'll set to be false for now. And we'll also have a variable our shoes laced, okay, which is going to be another boolean. Let's set this equal to false. Okay, so we have extra variables now that the shoes has access to, but clothing does not have access to. So what we'll do in here is create a couple of methods to help us lace our shoes, because this is initially set to null. So we'll want to set it up with some laces right away. We'll call upon a function called something like lace shoes. Okay, whatever we'd like to call it. We'll pass in a name, which is going to be a string. And then we're just going to set this.laces name equal to name. Okay, we're going to set this.ourLacesClean equal to true. We'll assume that when we're lacing shoes up, the laces are clean. And then we're going to set isShoes.ourShoesLaced also equal to true. Okay, so pretty cool so far. We have some more variables to test out, and we have a new method to test out. So let's go to main activity, where we're going to expand on what we did here previously. So now I can create a variable that is going to represent new shoes. Actually, let's call these like sneakers or something. And this is going to be an instance of shoes with laces. We're going to pass in a name and a string. So name is just going to be equal to sneakers. And let's say for size, let's do something like 10. Okay. So now this is of type shoes with laces rather than of type clothing. Weirdly enough, we can actually set this to be of type clothing. And there is still no errors here. Okay. Because we can do this where we can set a variable to be of the super type, but actually use the subtype. But we can't do this the other way around. Like if I declare this to be of shoes type, I can't then use the clothing constructor. That is going to cause me issues. Okay. So let's just put that back. Yeah, there we go. Okay, so now my sneakers, even though it's of type shoes, actually has all of those attributes. So we have is clean. We can access the name. We can access, the size as well. So it has all of the attributes of the superclass. We can also take our sneakers and we can wash them if we want. So we can wash clothing here. Okay. What we can't do is take our t-shirt. Actually, let's demonstrate down here. We can't take our t-shirt, and then we can't call upon laces. Okay. We can't call upon lace t-shirt up. We can't call upon our shoes laced or anything like that, because again, the superclass knows nothing about the subclass, but the subclass knows everything about the superclass. So let's say we got some sneakers, we want to lace them up, so we're going to lace these shoes with the name of, I don't know, checkered, let's do lowercase actually, checkered laces. Okay, not sure exactly if this is a name or a particular type of laces, but let's just go with this. Okay, so at this point, because I've called this method here, passed in this name, sneakers is now laced. My pair of sneakers are laced. They are laced with clean laces, and my laces now have this name. Now, what if I call upon the wash function? So I call upon sneakers.wash clothing. Okay, so that's fine. It'll wash the shoes. But what about the laces? Let's pretend my laces are dirty. Well, maybe I want to wash them as well without having to call an extra method. Well, for this, I can go to shoes and I can do what's called an override of my wash clothing. So I can have an override, okay, and I'm going to override my wash clothing, okay. my wash clothes. Oh, actually, I should probably say override function wash clothing. Okay, we're going to take in again nothing because there are no parameters there. Because this is final in my clothing class, I have to declare this as open. Okay, and that way, yeah, if I go back here, that gets rid of the issue. So what we'll do is we'll call upon our super.washClothing and we'll provide extra implementation. So in this case, I'm going to say our lace is clean equal to true as well. So we'll wash both the shoes and the laces at the same time. So now what this is doing is a little similar to with the constructor scenario. This is using the same function implementation. So again, no parameters, no return type, same function name. So we need to override it. Then we're going to call upon the superclasses washClothing method, which is going to just trigger this, and it's going to set the shoes is clean equal to true. And then we're providing some extra behavior. So this is called a function override. We can do pretty much the same thing with variables, and we can also provide new constructors. So same function signature as in name, parameters, and return type. So we have to call upon the override. We call upon the supers version to execute that function, and then we're going to provide some extra behavior. So at this point in time, if I call upon my wash clothing, now my laces are also being washed along with the shoes themselves. All right, so that is there's an intro into the concept of subclassing and superclassing. Like I said, there would be a lot more that I want to cover on even just that topic, but we're kind of out of time, as well as the entire topic of objects and classes. You can be programming in object-oriented languages for years and still not necessarily know all there is to know about this objects and classes, just because there are so many different types. Some objects and class types are better for certain scenarios, some are worse. And it's pretty difficult to know exactly which one to use in exactly which scenario. However, you now know enough that you can get started coding and can do some research of your own. I think the best way to get to know this stuff a little better is always to practice on your own time. So as always, I would really recommend that you do a little bit of practice. What I would actually strongly recommend you do is come up with some new scenario that involves a subclass-superclass relationship. So pick something other than clothing. Maybe a video game would be a good place to start because there are lots of objects in video games. Lots of objects might inherit from other objects. So maybe create your own custom classes and then superclass them. Try adding some extra functions and variables, and then try this kind of override system. And then once you're comfortable with everything, feel free to check out some of our other tutorials or just get started on your own Kotlin app development. So at the end of this section coming up, I'm just going to do a very, very quick outro and a summary of everything that we've covered so far. Okay, so do that practice. When you're ready, come on back to this outro. We're going to summarize everything, and then you can be on your way.